Hi everyone, this is Ms. Rosenthal. We're going to do notes for 3A of Unit 2, right triangles, and basically what we're going to do is see how we can use our trig ratios to help us solve some problems within triangles. So, just want to let you know, I saw a right angle resting under a tree this afternoon, and I thought, wow, 90 degrees in the shade. I know, they'll get better. So, first of all, we've got two different types of angles we're going to talk about today. One is the angle of elevation, which basically is the angle between looking straight out and then looking up to something, which they call the line of sight. So this angle right here is called the angle of elevation. Likewise, if I'm starting straight out horizontally, you can see this one's like from the balloon, and I'm looking down at somebody, this angle that I'm looking down is the angle of depression. So when I look at those two combined, you can see here in the middle, these are the horizontal lines, AB and CD. Horizontal lines are going to be parallel to each other. Okay, if you remember back with our work with parallel lines, we had these two angles here that would be alternate interior. They will be equal to each other, so the angle of depression and the angle of elevation will always be exactly the same. Okay, so let's see how this is used. The first example, a nursery plants a new tree and attaches a guy wire to help support the tree while its roots take hold. An 8-foot wire is attached to the tree and to a stake in the ground. From the stake in the ground, the angle of elevation of the connection with the tree is 42 degrees. Find the nearest tenth of a foot, the height of the connecting point on the tree. So you can see here they've taken this information and they've put it on a example here. Okay, if we want to, we can pull that triangle out, and when I do so, we still have the tree that is vertical here, and that's what we're trying to find of how far up this 8-foot wire goes. And they're telling me that this angle is 42 degrees. So once we have that information, then we have to look for our trig. So I've got this angle I'm noticing. This is my opposite side, and this is my hypotenuse. So opposite and hypotenuse indicate we must use sine. The sine of 42 degrees is going to be the opposite over the hypotenuse. Okay, so that's taking the information from the triangle and setting up our trigonometric ratio and our equation. Now we're going to solve this. So I'm going to take 8 times sine 42. Okay, when I do that, I get 5.353, and it just keeps on going. Okay, the direction said round to the nearest tenth. So that's the 3, so x is going to equal 5.4 because the one next to it is greater, 5 or greater. So my answer would be 5.4 feet, and that seems like a reasonable answer for that problem.